Hi students, hope that all of you are doing well. So please continue staying at your own homes and continue your studies. Today I am continuing with class 9 mathematics second chapter polynomials. Today we are going to study another very important theorem known as factor theorem. In the previous class we have studied remainder theorem. Today it is factor theorem. It is also in connection with the previous theorem, that is remainder theorem. What is factor theorem? You might have noticed the last question of the previous exercise was to check whether a given polynomial is the factor of the given polynomial. A px was given and another polynomial was given, say gx. Then we were asked to find out whether gx is a factor of px. And then what was the method we used? We have checked whether the remainder is 0 or not. Then I told you, if the remainder is 0, then gx is called a factor of px. When the remainder is not 0, gx is not a factor of px. Factor theorem also states the same. It goes like this. Let px is a polynomial of any degree. Let px be a polynomial of any degree and a, small letter a, be any real number. Let px be a polynomial of any degree and small letter a be any real number, then there are two versions for factor theorem. First one, x minus a is a factor of px. X minus a is a factor of px if p of a equal to 0. This is what we did in the previous class. If p of a is equal to 0, then x minus a is a factor of px. Actually, what do you mean by p of a? P of a is the remainder. When px is divided by x minus a, then the remainder is called p of a. That was remainder theorem. And if p of a equal to 0, means if the remainder equal to 0, then x minus a is a factor of px. Now, this statement can be given in this way also. P of a will be equal to 0 if x minus a is a factor of px. So this is the reverse statement. Suppose you are given a polynomial px and you are also given that x minus a is a factor of that given polynomial px. In that case we can say p of a will be equal to 0. Both of these statements will be useful in doing the questions. We are going to discuss the question answers of the next exercise. Then we will see the application of both the statements. So the first statement states that x minus a will be a factor of px if p of a equal to 0. So this statement will be used by us to check whether x minus a is a factor of px or not. How? By finding the value of p of a. If the value of p of a is 0, yes, x minus a is a factor. And in some other cases, you will be given a polynomial px and you will also be given that x minus a is a factor of this polynomial. Then we can say, then p of a will be equal to 0. Both will be used in the coming exercise questions. Now, I am moving to the next exercise. So this is a very important theorem known as factor theorem. Please go through the statement I hope you understood the statement as well as its meaning. Now I am going to do the exercise questions. The next exercise is exercise 2.4. Exercise 2.4, first question is, determine which of the following polynomial has x plus 1 a factor. So you are given 1, 2, 3, 4 polynomials below. In each of the 4 polynomials, you are asked to check whether x plus 1 is a factor of this polynomial or not. The first polynomial is x cube plus x square plus x plus 1. X cube plus x square plus x plus 1. Everywhere we have to check whether x plus 1. Whether x plus 1 is a factor of this polynomial or not. So the first step, let the given polynomial be px. So let px equal to x cube plus x square plus x plus 1. Now you just remember, in order to check whether x plus 1 is a factor of px, apply factor theorem. If x plus 1 is a factor, then what must be equal to 0? P of a must be 0. What is P of a in this case? P of minus 1. We have to check for x plus 1. So if P of minus 1 equal to 0, then x plus 1 will be the factor of this polynomial. So we have to check the value of P of minus 1. So straight away I am going to find the value of P of minus 1. So here P of minus 1 equal to minus 1 the whole cube plus minus 1 the whole square plus minus 1 plus 1. Minus 1 the whole cube is minus 1. Minus 1 the whole square is plus 1. Then again minus 1 plus 1. Minus 1 plus 1 cancel. Minus 1 plus 1 cancel. Answer is 0. Since P of minus 1 equal to 0, using factor theorem we can say, x plus 1 is a factor of px. Yes. So I repeat once again, in order to check whether x plus 1 is a factor of a given polynomial px, we have to find the value of P of a. Here P of a means P of minus 1. We got the value of P of minus 1 as 0. Since P of a equal to 0, x plus 1 is a factor of px. I will do only one more of question number 1. 4 questions are there, 4 polynomials are given. The first one is done. I am leaving second one and third one as homework for you. Both are very easy. Fourth one is little complicated, so let me do it. Fourth one is x cube minus x square minus bracket 2 plus root 2 into x plus root 2. We have to check whether x plus 1 is a factor of this polynomial or not. So the first step, let px equal to given polynomial. So let px equal to, you may write down separately. Okay, you have to write down one more line. So let px equal to given polynomial. Since we have to check it for x plus 1, we have to find the value of p of minus 1. P of minus 1 means minus 1 the whole cube minus 1 the whole square minus 2 2 plus root 2 in bracket into minus 1 plus root 2. Minus 1 the whole cube is minus 1. Minus 1 the whole square is plus 1. Plus 1 into minus 1. See, minus into minus 1. It is plus 1. Here there is a minus and you have to multiply it by minus 1. So minus into minus 1 plus 1. So it is plus 2 plus root 2. Plus root 2. Minus 1 minus 1 minus 2. Minus 2 plus 2 cancel. But root 2 plus root 2 is 2 root 2. So we will write, since p of minus 1 is not equal to 0, x plus 1 is not a factor of px. X plus 1 is not a factor of px. I hope you understood. The calculation was little complicated, that way I have done. Otherwise the method is same. So take care of it. Okay. Now moving to question number 2. Question number 2. Use factor theorem to determine whether gx is a factor of px in each of the following cases. Now, you are given a px and in front of each px you are given a gx. In every question you have to check whether gx is a factor of px or not. Same thing, same question. In question number 1, gx was same for all the px. Gx was x plus 1. Now, in place of that x plus 1, for each polynomial, gx is also changed. For example, first one, you are given a polynomial px and gx is given x plus 1. Same as question number 1. So, you have to find the value of p of minus 1. If p of minus 1 equal to 0, you can write gx is a factor of px. Second one, gx is x plus 2. So, you have to find the value of p of minus 2. If p of minus 2 equal to 0, yes. If not 0, then no. In third one, gx is x minus 3. So you have to find the value of p of 3. If p of 3 equal to 0, yes, gx is a factor. Otherwise, no. So please do it as homework. Same as question number 1. Now moving to question number 3. Question number 3 is, find the value of k, small letter k, if x minus 1 is a factor of px in each of the following cases. This is the second statement use of factor theorem. You are given or you are asked to find the value of k if x minus 1 is a factor of px. You are given 1, 2, 3, 4 px. 4 polynomials are given. And it is also given that x minus 1 is a factor of this polynomial. Then find the value of k. In each of the polynomial px, there is a k. So, we have to find the value of k. First one. So, this is question number 3. In question number 3, the first one is px equal to x square plus x plus k. Remember, we are given x minus 1 is a factor of px. If x minus 1 is a factor of px, find the value of k. Here you can see a k. So how will you begin? Since x minus 1 is a factor of px, since x minus 1 is a factor of px, what can you say? P of 1 equal to 0. I hope you got it. Since x minus 1 is a factor of px, by using factor theorem we can say P of 1 equal to 0. Now put P of 1 equal to 0 in the given polynomial. P of 1 means that is 1 square plus 1 plus k equal to 0. 1 plus 1 plus k equal to 0. 1 plus 1 2. 2 will be taken to RHS, so k equal to minus 2. Got it? Since x minus 1 is a factor of px, using factor theorem, P of plus 1 equal to 0. Remember, here if it is minus, then here it will be plus. We have done P of 1 equal to 0. While doing, we got the value of k. Another polynomial is given. 3 more are given. Let me do now question number 3. Now its third part. Third part is px equal to kx square minus root 2x, kx square minus root 2x plus 1. Okay, same thing. Since x minus 1 is a factor of px, using factor theorem we can say P of 1 is equal to 0. That is P of 1 k into 1 square minus root 2 into 1 plus 1 equal to 0. P of 1 equal to 0. That is k into 1 square is k minus root 2 plus 1 equal to 0. Keeping k here and taking the other two terms to RHS, it becomes root 2 minus 1. So the answer is k is equal to root 2 minus 1. So this is the use of factor theorem. So factor theorem can be used in two ways. It can be used to check whether a given binomial is a factor of the given polynomial or not. How? By finding the value of P of A. That was done in question number 1 and 2. Here you are already given x minus 1 is a factor of px. That was the second statement. If x minus a is a factor of px, then we can say P of a equal to 0. Since x minus 1 is the factor of px, everywhere P of 1 will be equal to 0. When you do P of 1 equal to 0, you will get an equation in k. You will get an equation in k. While solving that equation, you will get the value of k. So that's all for today. Today we have discussed a very important theorem in algebra, that is factor theorem. So factor theorem is to check whether a binomial polynomial is a factor of another polynomial px or not. I repeat the statement once again. Let px be any polynomial of any degree and a is any real number. Then, number 1, if P of A equal to 0, then x minus A will be the factor of Px. Second, if x minus A is the factor of Px, then P of A equal to 0. And we have seen the application of both in these two type questions. So, please do the homeworks, go through the video once again, understand the things and do the homeworks, and please do extra questions of the same type. Please take care of you. Till then, bye bye.